In the last video, we met the notion of synthetic division, and we saw how that can be used to complete certain polynomial long division problems more easily than we could using the full process of polynomial long division. In this video, we'll meet the full procedure for synthetic division. Now, this is going to feel like a lot of steps. Synthetic division is one of those procedures in math that feels weird the first few times you do it, but then after you practice a few times, it starts to be easy. So if this feels like a lot of steps, don't worry. All it's going to take is a little bit of practice. In order to use synthetic division, our divisor has to be in the form x minus some number. Now here our divisor is x plus 3, but that's the same as x minus negative 3. So our k is negative 3. Now, we saw when we previewed synthetic division that in order to avoid subtraction, we want to take the opposite of the number that appears in the divisor. So we'll write negative 3 in the upper left-hand corner of the space where we're going to work, and we'll put a bracket around it. Notice that the number that we write is just the value of that k. It's just what's being subtracted from x. So here's our workspace. I'm going to put my negative 3 in the upper left corner, and I'm going to put a bracket around it. So that's the divisor dealt with. Now we're going to deal with the dividend. We write the coefficients of the dividend in order to the right of that number. Just like in regular polynomial long division, they have to be in order and we have to include any zeros. In our example, the coefficients in the dividend are 2, we've got a 2x to the third. 1, we've got just x squared by itself. Negative 13, we have negative 13x. And negative 1, we have negative 1 for our constant. Now we make a line underneath our row of numbers, leaving space for another row in between. Okay, we are done with our setup. In order to get the synthetic division process started, now we copy our first coefficient below the line. In our example, this is the number 2. And now we're ready for the main loop of synthetic division. First, we multiply the number we just wrote by the number in the bracket. So we'll multiply by negative 3 here. 2 times negative 3 is negative 6. Then we add down the column. 1 times negative 6 is negative 5. And now it says to repeat these steps until we filled all the columns. Multiply by negative 3. Negative 5 times negative 3 is 15. Add down the column. Negative 13 plus positive 15 is positive 2. Multiply, add. Multiply, 2 times negative 3 is negative 6. Add, negative 1 plus negative 6 is negative 7. Multiply, add. And now we've filled all the columns. It says the last thing we need to do is make a vertical line before the last number. Why are we doing that? Well, that's going to help us in our next step. After we've finished doing synthetic division, we have to read our answer. We need to figure out where the x's go in our answer, in particular. To do that, we use the fact, well, we're dividing by something with degree 1, So the degree of the quotient is going to be 1 less than the degree of the dividend. In our example, our first term is 2x to the third. That's our highest degree term. The degree of our dividend is 3. So the degree of our quotient will be 3 minus 1 is 2. We'll start with an x squared in our leading term. So we'll have 2x squared, and then we fill in the variables in descending order. So after x squared, we have a negative 5x to the first, that's just x, plus 2. The last number before the vertical line is the constant. So 2 is the constant. If that's not what you get when you fill in descending order, something went wrong. And then that last number after the vertical line is going to be the remainder. So when we did that division, we got 2x squared minus 5x plus 2, and then our remainder is negative 7. We put that over x plus 3.